Dear students and friends, Assalamu alaikum. You are watching NPTEL Chemistry E class and I am your chemistry detective. Yes, you read it right. Today I will solve problem based on idea of limiting reagent. Limiting reagent is the reactant whose available quantity or available amount is less than stoichiometric amount. I mean is less than required amount. And what happens during the course of reaction, whatever its amount is available, whatever amount or quantity we take it to start a reaction, it gets completely consumed, it gets completely reacted, nothing leaves behind, nothing is left behind in terms of quantity of this limiting reactant. And it is this limiting reactant or reagent which decides the fate of reaction. It decides how much quantity or available amount of other reactant will get consumed, and it is this limiting reagent which decides how much product in terms of mass or moles will be formed in a particular reaction. Therefore, our problem is based on idea of limiting reagent. Now, in this problem, we are given a reaction A plus B2 gives AB2. Now, we have to identify the limiting reagent in this reaction, if any, and it is said that we start reaction taking mixture of 300 atoms of A and 200 molecules of B2, and next time we start same reaction taking mixture comprising of 2 moles A and 3 moles of B2. Third time we start same reaction comprising of mixture comprising of 100 atoms A and 100 molecules B2. Similarly, once again we start same reaction with mixture comprising of 5 moles A, 2.5 moles B, and at last we start this reaction with mixture comprising of 2.5 mole A and 5 moles of B. So basically in this question we have to identify presence of limiting reagent, existence of limiting reagent in five parts. Let me take first part. First part is, first I will write reaction. Reaction is A plus B2 gives AB2. This is reaction, and this is balanced chemical equation. In balanced chemical equation, stoichiometric coefficients of reactants and products determine their moles or atoms or molecules. For A 1 mole, for B 1 mole, and for AB2 1 mole. And for this we can write 1 mole atom because it is atomic. For this we can write 1 mole molecule because it is molecular. Here we can also write 1 mole molecule because it is molecular. 1 mole molecule. Or else I can write, if 1 atom of A reacts, that time 1 molecule of B reacts, and same time 1 molecule of AB2 is formed. This is the information conveyed to me by this balanced chemical equation regarding this chemical reaction between A and B2 resulting in formation of AB2. These are stoichiometric amounts. These are stoichiometric amounts of reactants A and B2 that are required to be maintained in this reaction. and these are required amounts of reactants in terms of atoms and molecules that are required as demanded by this reaction. For 1 atom of A, we should take 1 molecule of B2, and for 1 mole of A, we should take 1 mole of B2. Basically, it is a 1:1 reaction. Stoichiometry is 1:1. For each atom of A, we have to take 1 molecule of B2, and for each mole of A, we have to take 1 mole of B2. Now, let me take part first. Part first, we start with mixture comprising 500 atoms. 500 atoms of A. 300 atoms of A and 200 molecules of B2. 200 molecules of B2. Yes, I read it perfect. Now, identify first, have in mind first what is the stoichiometric ratio, what is the desired ratio or demanded ratio or required ratio. For 1 atom of A, I need 1 molecule of B2. Now, given is 300 atoms of A, and in the mixture there are 300 atoms of A and 200 molecules of B2. For 300 atoms of A, it was required that we should have 300 molecules of B2, but number of molecules of B2 are only 200. Therefore, in this reaction, B2, or I can write B, is limiting reagent. B is limiting reagent. I hope you got my point. Desired is that ratio between number of atoms of A and number of molecules of B2 should be 1:1, but here ratio is 3:2, or I can say for 3 atoms of A, it was desired to have 300 molecules of B2, but number of molecules of B2 are only 200. Therefore, in this reaction, in this mixture comprising of this many number of A, this many number of atoms of A and this many number of molecules of B2, in this mixture, A is excess reactant, excess, but we have to identify limiting reagent, so I will say B is limiting reagent. Now, taking second part. In second part, we start with mixture comprising 100 atoms of A and 100, in second part we start with 2 mole A, 2 moles of A and 3 moles of B2. Stoichiometric ratio between moles of A and B2 is 1:1, but here ratio is 2:3, and it is desired thing is that for 2 moles of A, I should have 2 moles of B2, but number of moles of B2 are 3, more than 2. Therefore, in this mixture, B2 is excess reactant and A is limiting reagent. Let me write its answer here. A is limiting reagent. Right? I hope you got my point. A is limiting reagent. Now, I will take part third. Part third is 100 atom A plus 100 molecules 100 molecules B2. See here, this mixture is interesting because in this mixture we start with equal number of atoms and molecules of A and B2 respectively. 100 atoms of A and 100 molecules of B2. Ratio is 1:1. For 100 atoms I need desired was 100 molecules of B2, and so is the case. Therefore, here stoichiometric amounts are present for both A and B2. For both reactants, both reactants are present in their stoichiometric amounts. I will write both reactants are present in stoichiometric amount, are present in required amounts or stoichiometric amounts. Therefore, no limiting reagent. Here no limiting reagent. In this mixture there is no limiting reagent. No limiting reagent. So far only in part third we found that in the mixture of A and B2 there is no limiting reactant. Both the reactants will get consumed 100%. Both the reactants will react complete. Whatever amount we take of A and B2, they will get completely consumed. 100 atoms of A will get consumed and 100 molecules of B2 will get consumed. Now part fourth. Part fourth is 5 mole A and let me rub this portion. Part fourth is 5 mole A and 2.5 mole B. You can do it yourself now. Desired ratio between moles of A and B2 is 1:1. It means for 5 moles of A we should have 5 moles of B2, but number of moles of B2 are only 2.5, less than 5. Therefore, in this mixture A is excess reactant and B2 is limiting reactant, and we need to identify limiting reactant. So I will write limiting reagent or limiting reactant is B or B2. Last part is 2.5 in mixture. We start with the mixture comprising of 2.5 moles of A and 5 moles of B. Now situation in part mixture fifth is opposite to that of mixture fourth. You see, desired ratio you have now in mind, it is 1:1. For 1 mole of A we should have 1 mole of B2. That demands for 2.5 moles of A we should have 2.5 moles of B2, but number of moles of B2 are 5, which is greater than 2.5. Therefore, B2 in this mixture is excess reactant and A is limiting reactant, I solved all the parts. For mixture first, limiting reagent is B. For mixture second, limiting reagent is A. For mixture third, no limiting reagent, and for mixture fourth, B is limiting reagent, and for mixture 5th, A is limiting reagent. Now I will summarize this problem for you. This problem is from Chemistry class 11th NCERT book. It is based on concept of limiting reagent. I said limiting reagent or limiting reactant is the reactant whose available amount or quantity is less than stoichiometric amount or stoichiometric quantity. And during course of reaction, whatever amount of it we start with the reaction, whatever available amount we have of this limiting reagent, it gets completely consumed, it reacts completely, nothing is left behind, and it is this limiting reagent that decides the fate of the reaction, that decides how much amount in terms of mass or moles other reactants are consumed and how much amount of product in terms of mass or moles are formed. And the other reactant which is present in excess, whose available amount is greater than stoichiometric amount, required amount, that is called excess reactant. And at reaction end, there is always some portion of some amount of that reactant left unreacted, unconsumed. And in this problem, we started with mixture comprising 100 atoms of A and 200 molecules of B2, and reaction is A plus B2 gives AB2. This balanced, from this balanced chemical reaction, quantitative information is that for 1 mole of A we need to take 1 mole of B2, and for 1 atom of A we need to take 1 molecule of B2. This is the stoichiometric ratio or required ratio of moles or atoms of A and B2 with which we have to start, which we have to maintain during the course of this reaction, or which we have to start with. And in first case we see that for 300 atoms of A we should have 300 molecules of B2, but number of molecules of B2 are only 200. It means B is the limiting reagent and A is the excess reactant. In part second, 2 moles of A and 3 moles of B2. For 2 moles of A we should have 2 moles of B2, but we have 3 moles of B2 which is greater than 2. Therefore, B is excess reactant and A is limiting reactant. In part third, we start with 100 atoms of A and 100 molecules of B2, which is stoichiometric ratio, demanded ratio 1:1. Here both A and B2 are present in their stoichiometric amounts, required amounts, no limiting reagent is present. And in part 4 we start with 5 moles A and 2.5 moles B. It was demanded that for 5 moles of A we should have 5 moles of B2, but number of moles of B2 are only 2.5, less than 5. Therefore, B2 is limiting, B is limiting reagent and A is excess reactant. In last part we start with 2.5 moles of A and 5 moles of B2. It was desired that for 2.5 moles of A we should have 2.5 moles of B2, but number of moles of B2 are, we start with 5 moles of B2 which is greater than required amount 2.5. Therefore, B in this reaction is excess reactant and A is limiting reagent. In this way I was able to identify limiting reagent in all the 5 mixtures, and I found that in first B is limiting reagent, in second A is limiting reagent, in third there is no limiting reagent, in fourth B is limiting reagent, and in last part fifth A is limiting reagent. Thank you. This is what I have got for you in this short session. Take good care of yourself. Allah Hafiz. See you tomorrow with one new chemistry class 11th NCERT problem.